What's up everyone? For today's video, we will learn about another type of conic section, ellipse. And our goal is to determine if an equation is an ellipse and how to graph it. So, let us first define the ellipse. An ellipse is a conic section where it is a locus of a point in a plane that moves such that the sum of its distances from two fixed points is constant. Meaning, no matter where you draw a point on the ellipse, the sum of the distance of focus 1 and focus 2 from the point is always the same. Ellipse has two standard equations, horizontal and vertical, but we will focus on the horizontal standard equation. Let me introduce to you first the parts of an ellipse: center, foci, vertices, major and minor axis. Take note of these parts because we will use this later in our discussion. So, the general equation of the ellipse is ax squared plus cy squared plus bx plus dy plus e is equal to 0, where a is not equal to c and a and c is not equal to 0. While the standard equation of the horizontal is x minus h quantity squared over a squared plus y minus k quantity squared over b squared is equal to 1, where a is the distance from center to vertex, b is the distance from center to end of minor axis, c is the distance from center to focus, and the distance from focus to other half of latus rectum is b squared over a. As you can see on the screen, those are the formulas for the parts of an ellipse. Take note of these formulas as well, as we will further discuss and use this later on as we solve on this sample problem. Determine the center, vertices, minor axis coordinates, foci, and lateral recta of the equation 16x squared minus 25y squared minus 64x minus 50y minus 311 is equal to 0. Then draw its graph. First, we need to reduce the equation to its standard form. So isolate the constant negative 311 and combine similar terms. Note that we can factor this out to make it easier to solve, and it will result to 16 multiplied to quantity x squared minus 4x plus 25 multiplied to quantity y squared minus 2y is equal to 311. Then we will solve this equation using completing the square to make the left-hand side a perfect square trinomial, where we add the result of b over 2 quantity squared to both sides of the given equation. So we added the product of 16 to 4 and 25 to 1 in the other side of the equation for the equation to be balanced. Remember that whatever we input to one side of the equation should also be inputted on the other side. Last, factor out the equation using perfect square trinomial and simplify. Following the standard equation of the horizontal, we simplified the equation, resulting to x minus 2 quantity squared over 25 plus y minus 1 quantity squared over 16 is equal to 1. Since we already know the equation's standard form, we can now determine its parts. We know that the center is always hk, therefore the center of the ellipse is 2, 1. Now we can just simply follow the formulas on the remember board so we can get the coordinates of the parts of an ellipse. Therefore, the coordinates for the vertices are 7, 1 and negative 3, 1, while the minor axis coordinates are 2, 5 and 2, negative 3. The foci coordinates are 5, 1 and negative 1, 1, while the coordinates of lateral recta are 5, 21 over 5, 5, negative 11 over 5, negative 1, 21 over 5, and negative 1, negative 11 over 5. After that, we can now graph the ellipse since we already know the equation's standard form and its parts. We just need to plot the coordinates we got. Then we can now draw the ellipse as well as its major and minor axis, and the graph's done. Now, going back to our goal, we can say that we were able to recognize the standard equation of an ellipse, and we were able to graph it using the given equation. To better understand and grasp the ellipse concept, now, it's your turn. Try to satisfy the conditions on the screen. See you next time as Archimedes awaits you. Subscribe to our channel and click the notification bell to be updated for our next videos.